Okay, so today I'm going to start chapter 11. I'm going to go over exponential and functions. Let's start 11.1. We're going to do two things: algebra of functions and composite functions. Alright, so algebra of functions and composite functions. Let's start with algebra of functions. So if we're given two functions, function f and function g. If for each input x into f we get exactly one output y, and that y we label as is the output for an input x using machine f, an output y for an input of x into machine f, and that's gonna give me y equals f of x. Same thing here. If we input x into g, we're gonna get a y value, exactly one y. That's why it's a function, and that y is produced using an input x in machine g. That's why we use f of x here and g of x there. Now if we want to make up a new machine, that new machine we're gonna call f plus g, and we want to input x in there, and we're gonna get an output y, which is f plus g of x. But what is that f plus g of x? By definition, the way we want it, it's gonna be defined as f of x plus g of x. What is f of x? It's the y value that you get from f. What's g of x? It's the y value that you get from g. And we can do the same thing for minus, times, and division. So we can define, so I'm gonna rewrite what we just did. F of x is f of x plus g of x. You can remember it like distributing, but it's not timesing though. Remember, f of x is a y value, g of x is a y value, just using two different machines, okay? F minus g of x is f of x minus g of x. F times g of x is the output from f times the output from g, and f over g of x, it's f of x over g of x, as long as you don't divide by 0, okay? And if it was g over f, then you do g on top and f on the bottom. Okay, all this is actually summarized in a handout that's in your notes. So if you look at the notes, here's combination of functions. These are all the functions we just defined, and we're gonna talk about it right here, so you can read that, but I'm gonna write it down. And then we're gonna get composite. That's the second topic, okay? So just make sure you go over that. So what is the domain? So remember, domain is any value x goes into f, so you can get a y value. Domain of g, any value of x you input into g, so you can get a y value. Same thing here. Domain of f plus g is all real numbers x, where when you put it into f plus g, you're gonna get a y value. So domain of f plus g, f minus g, and f times g. I'm gonna leave f over g by itself. You'll see why. Is all real numbers that are in the domain of f and in the domain of g. Why is that? In other words, it's going to be where the two domains overlap, where the two domains overlap. Why is that? Because any x to be inputted into f plus g, it has to be accepted by f and accepted by g. That's how we define it. So you have to be able to put it in f and in g. That's why if f only takes positive numbers, then fg only takes positive numbers. If f takes 0 and 1, then f plus g only takes 0 and 1. If g doesn't take fractions, then f plus g cannot take fractions. Okay. Now, why I leave f over g by itself? Because g cannot be 0. So domain of f over g, again, it's all this and such that g of x does not equal 0. So it's going to be everything in the domain of f and everything in the domain of g where they overlap, but make sure you exclude the values where g equals 0. Make sure you exclude the values where g equals 0. So let's look at an example. So we're given two functions, f of x equals square root of x and g of x equals x minus 2. So find several things. The first thing that we need to find is f plus g of x. Again, by definition, it's f of x plus g of x. We have f of x, so we plug it in, and we have g of x. And the reason for this is now we have an equation for f plus g, just like we have an equation for f and an equation for g. So now, if I want to find, say, f plus g of 9, I don't have to do f of 9 plus g of 9. All I have to do is plug the 9 in there. So it will be square root of 9 plus 9 minus 2. That's 3 plus 7 is 10. Could I still do it by plugging it? Of course, you can do in f, g, and then add them up, but this is just straightforward. Okay, second question, what's f minus g of 4? Now, since I don't have an equation for f minus g, I'll just do f of 4 minus g or. Okay, f of 4 is root 4, and g of 4 is 4 minus 2. So 2 minus 2, which is 0. Okay, part C, number 3, f times g of 4. Again, it's f of 4 times g of 4. We just said f of 4 is root 4, which is 2, and g of 4 is 2. 4 minus 2 is 2. 2 times 2 is 4, so f times g of 4. And finally, f over g of 4 is f of 4 over g of 4, which is 2 over 2, which is 1. And if I wanted to say f over g of x, it's f of x over g of x, which is root x over x minus 2. Okay, I just added 5 right now. It's not in the notes. Now, what's the domain of f plus g, f minus g, and f times g? Okay, so to do that, we're going to find individual domains first. What's domain of f? What's domain of g? And then we're going to see where they overlap. Domain of f, if you look at f, it's square root of x, so it cannot have negatives. So it's 0 to infinity. G, you can plug in a positive, a negative, because it's a polynomial, it's linear function, so it's negative infinity to infinity. So where do these overlap? G is all this, and f is 0 to infinity, so you can see where they overlap, 0 to infinity. So domain of f plus g, f minus g, f times g is 0 to infinity. Now, what's the domain of f over g? Domain of f over g, it's going to be all this, 0 to infinity, minus, we're going to remove from that where g equals 0. See, g equals 0 minus where g of x equals 0, but g equals 0 when x equals 2. So it's 0 to infinity minus 2. So if you look at 0 to infinity, and then if you want to take away the 2, then you're going to do 0 to 2, 2 to infinity with parentheses. So domain of f over g is 0 to 2 union 2 to infinity. Okay, so it's always for f over g, whatever you got for f plus g, f minus g, m times g, minus where the bottom equals 0. Where the bottom equals 0. If it was g over f, then minus where f equals 0. Okay? Alright, here's another one. Alright, example 2. Set f of x equals 3x plus 2 and g of x, x squared minus 9. Find f plus g of x. So by definition, it's f of x plus g of x. 3x plus 2 plus x squared minus 9. You cannot leave it like this. You gotta organize it. X squared first plus 3x. And then 2 minus 9 is negative 7. F plus g of x. So we got an equation for f plus g, just like we have an equation for f, and we have an equation for g. So now, number 2, if I want to find f minus g of 2, it's f of 2 minus g of 2. So back here, f of 2 is 3 times 2, 6. 6 plus 2 is 8. G of 2 is 2 squared minus 9. 4 minus 9 is negative 5. Okay? So f of 2 is 8. G of 2 is negative 5. 8 minus negative 5 is 13. And that's f minus g of 2. Now, number 3, f times g of x. We don't have a number to plug in, so we're going to get the equation for f times g. So it's f of x times g of x, which is 3x plus 2 times x squared minus 9. So let's work it out. FOIL 3x cubed minus 27x plus 2x squared minus 18 in descending order. 3x cubed plus 2x squared minus 27x plus 18. I switched these around. Okay. Number 4. What is f over g of 2? It's f of 2 over g of 2. We already have f of 2 is 8 and g of 2 is negative 5. So now domain of f plus g, f minus g, and f times g. In order to do these three domains, we gotta find domain of f and domain of g and see where they overlap. Okay, let's look at f. F is 3x plus 2. It's all real numbers because you can plug in negative, positive, whatever you want. Domain of g, again, x squared minus 9. It's all real numbers. So where they overlap, it's all real numbers. So domain of f plus g, f minus g, f times g is also what? All real numbers. What's domain of f over g? So it's all real numbers minus, you're going to remove where g equals 0, but g is x squared minus 9. So x minus 3, x plus 3, we factor it using the difference of two squares, so x equals 3 and x equals negative 3. So it's all real numbers. From negative infinity to infinity, we're gonna remove 3 and negative 3. To remove negative 3 and 3, we're gonna go from negative infinity to negative 3, then negative 3 to 3, then 3 to infinity. So domain of f over g is negative infinity to negative 3, union negative 3 to 3, and union 3 to infinity. Alright, and that will do it for the first part of 11.1. 11.2 is about composite functions. Composite. So now instead of putting the functions side by side and let x go into f and then x goes into g, I'm going to do it a little differently. I'm going to still input x into f. It's going to give me y or f of x. Now, instead of inputting x into g, I'm going to take the output from f, which is f of x, and input it into g. It's going to give me g of f of x, g of f of x. This g of f of x, it's called g composite f of x. G, and instead of writing composite, we use circle, okay? And of x, parentheses x, g composite f of x. So when you see g composite f of x, it's exactly what you see here. We're inputting f of x into g. What are we doing? We're inputting f of x into g. How do I know that? I always look at the closer letter to x, and that's the one that's inputted into the outer one, okay? This is g of f of x, so you're inputting f of x into g. Now, if you reverse that, if you put g and then f, g and then f, and you input x into g, you get a y value of g of x, then you input that into f, so you get f of g of x. So you're inputting g into f of g of x is f composite g of x, and you are inputting g of x into f. Do we get the same result? No, we do not. It doesn't have to be the same result. And here's a nice example. Okay, it's in your handout right here. Suppose you have a $25 coupon and a 50% off coupon that you want to use to buy a $200 sunglasses. Okay, so you went to the store and you have $25 off coupon. And then you get in there and they say you can use 50% off coupon that they have in store. So, but you want to use them concurrently, so you want to use them. So which one do you use first and which one would give you a better deal? That's the question. So if f of x is the 50% off, so the x is the original price, and you take 50% off, so x minus 50% off, so you're paying 50% of x basically, which is $100. And then g of x, it's the $25 off, so it's going to be x minus 25, or $200 minus 20, which is 175. Okay, so look what you do. If you do f of x, basically this is a general example. If you use the $200 sunglasses and you want to do, say, let me explain that, make it easier for you. So if x is $200, okay, and so f of x is going to be 50% of 200, which you end up paying $100. For g of x, it's, so this is basically 50% of x. Now this is x minus 25, 200 minus 25, which is 175. Now if you do f composite g of x, which is f of g of x, you're doing g first, okay? So g of x is going to give you 175, so you're doing f of 175, and f is going to give you 50%. What's 50% of 175? So you end up paying 50% times 175, you end up paying 87.5. That's if you were to do the $25 off, then the 50%. Now if you do the other way around, if you do 50% off first, g of f of x, so x is 200, you take 50% of 200, 100, and then you take a $25 off, so you end up paying $75. So of course this is better deal. So you can see f composite g is not the same as g composite f. Okay, so when you do the $25 off first, you end up paying $175, and then 50% off, you get 87.5. When you do the 50% off, you get 100 and then 25 of that, so it's better to do it that way, $75 instead of 87.5. Okay, this is the general deal, that when you plug in the 200, it gives you a better answer, an easier answer. It's in the notes. All right. Also, there's a worksheet that I want you to do. This is something I did do actually in class, in the lecture, but this is also, it should be helpful for you to do, okay? So work it out. And the handout that I talked about in the notes, the second part of it, it talks about composite functions in details, and then it shows examples, so make sure you go over those, okay? And this part is about the inverse of a function, which is 11.2, the bottom part. We're going to talk about that. Here's another example about composite functions. So let f of x equals square root of x and g of x equals x plus 3. Find f composite g of 6. So g is closer, so we're going to do f of g of 6. So g of 6, if you look over here, it's 6 plus 3, which is 9. So we're doing f of 9 because 9 is g of 6. So what does f do? It square root the 9 and gives you a 3. So what is f of g of 6? It's 3. Again, one more time. F composite g of 6. So we always start with the function that's closer to the number. Okay, g of 6 first. We plug the 6 into g right there. 6 plus 3 is 9. G of 6 is 9, so we put in a 9 for g of 6. We get f of 9. What do? We plug the 9 in for x right there. Square root of 9 is 3. Okay. Now let's reverse this. G composite f of 6. So it's g of f of 6. So we're going to plug the 6 first into f. It's going to give us square root of 6. And then we're going to plug that into g. So it's going to do root 6 plus 3, which is just root 6 plus 3, which is definitely different from number 1. Okay, so reversing the function doesn't give you the right answer. Okay, now we're going to do the general equations, which is a little bit more difficult. So number 3, we're going to do f composite g of x, which means you're inputting g of x into f, so there's no number to plug in. G of x is all this, so we're going to input x plus 3 into f. So x plus 3 is going to overtake x. It's going to be square root of x plus 3. Okay, so again, the closer letter to the function, to the closer function to the letter first. G of x is x plus 3. We're going to input all of x plus 3 in there, so x plus 3 is going to overtake x, and that's what we end up with. No numbers to plug in. Now let's reverse that. G composite of x, it's g of f of x, so we're inputting f of x into g. F of x is root x. We're going to input that into g, so this is going to overtake x, so it'll be root x plus 3. Okay. All right, let's see more examples. Let f of x equals 5x minus 4, and g of x is x squared plus 2. Find f composite g of 0. So by definition, we're going to do g of 0 first. So we're inputting a number, which is good. Inputting 0 into g. So let's do that on the side. G of 0 is 0 squared plus 2, which is 2. So we're going to take the 2 and put it in there. So we're going to do f of 2. Now 2 is going to go into f. So it's going to give me 5 times 2 minus 4, which is 6. Okay, number 2, g composite f of 1. So f is closer to 1, so we're going to do f of 1 and then g of that right there, f of 1. is 5 times 1 minus 4, which is 5 minus 4 is 1. So we're going to put in 1 for f of 1. We're going to input that into g, so it'll be 1 squared plus 2, which is 3. 1 plus 2 is 3. Okay, now the general functions. So let's do that on a fresh piece of paper. So we're going to do f composite g of x. Again, that means we're going to input g of x into equation f, into the equation of f. No numbers to plug in. So g of x is x squared plus 2. We're going to put that in there. And then we're going to input this whole expression into there. So we're going to take x out and put in whatever that is. So 5, to times it by all this, and we need parentheses, and then minus 4. Distribute, it's 5x squared plus 10 minus 4, which is 5 squared plus 6. And this is f composite g of x. We're going to reverse that now. We're going to do number 4, which is g composite f of x. Which means we're going to input f of x into g, but f of x is all that. We're going to take whatever inside the parentheses and put it in for x. We're going to square it and then add 2. Now it's probably a good idea to work it out, FOIL it. So it'll be 25x squared minus 20 minus 40x. Plus 16, and then plus 2 is plus 18. Okay. Number 46, page 908 in your book. Let's all look at page 908 in the textbook. Page 908, number 46. Oh, we have to be looking at the graph. It says refer to the graphs at the right and find the following. Part A, if you look at the graph, you want to find f over g of 0, which is f of 0 over g of 0. If you look at the graph, f is the red graph and g is the blue graph. So f of 0 is 2. And the blue graph, g of 0 is negative 1, over negative 1 is negative 2. Part B, f composite g of 3. So we're going to do f of g of 3. Again, from the graph, g of 3, g is the blue one, g of 3 is negative 3. So we're going to do f of negative 3, that's the red graph, f of negative 3 is 1. And that would be the final answer. And part C, g composite f of 2. So it's g of f of 2. So f is the red graph, f of 2 is 3. And g is the blue graph, g of 3 is negative 3. And that would be the answer. Alright, next we're going to do 54, page 908. 54, page 908. Says, so we're given the composite function, find the individual function. So h of x is the composite function. Usually we're given individual and find composite. Now it's the other way around. So h of x is cube root of 10 minus x. They want us to do, and h of x is f of g of x. And what is g and what is f? So g is the inner, f is the outer. That's how you should look at it. G is the inner, right? F is the outer. Inner is 10 minus x, so g of x is 10 minus x. F is the outer, so it's cube root of x. And that's going to give you, when you do the composite of f and g, it's going to give you a cube root of 10 minus x. Alright, let's look at last one from this section, 88, page 909. It says a high pressure area promises increasing warmer weather for the next 48 hours. 88, page 909. The temperature is now 34 degrees Celsius and is expected to run degree every 6 hours. Write a composition function that expresses the Fahrenheit temperature as a function of the number of hours from now. So the temperature now, which is at T equals 0, the temperature is 34 degrees Celsius. And it's expected to rise 1 degree every 6 hours. So when it's 6 hours, C is 34 degrees plus 1, which is 35. At 12 hours, it's 34 degrees plus 2. At 18 hours, it's 34 plus 3 degrees, and so on. So we want to write a composite function that expresses the Fahrenheit temperature as a function of the number of hours from now. So basically 1 is 6 over 6, 2 is 12 over 6, right? So you can see 6 over 6, 12 over 6. This is 18 over 6. So C of T is 34 plus T over 6. That's the formula they're looking for. Okay, we also know that F of C, we know the formula, 9 over 5 C plus 32. Okay, Fahrenheit and Celsius, that's the formula. So if you want to take C and put it in there, so we get F of T equals 9 over 5, 34 plus T over C over 6 plus 32. And then you work it out, you distribute 9 times 34, so it's 306 over 5 plus 9 over 5 times T over 6 is 3 over 10T plus 32, which would equal 3 over 10T plus 466 over 5. All right, that's it.